Hey, this is Mr. Radian. This is Chapter 4, Trigonometric Functions. We're in a new chapter here, and we're kind of in an even new group of topics, which is dealing with mainly trigonometry. And trigonometry is a fancy word for triangles. So we can do a little bit of triangles for a while. And we're going to start with Section 4.1, which is radian and degree measurements. Radian degree measurements. And so in trigonometry, we're really talking about triangles. And how do we have a triangle? Well, we have an initial side. We have a a terminal side as well. And that makes up a triangle ultimately. We can kind of connect those two vectors together. And when we connect those two vectors together, you can see it makes up a triangle. Okay? And so as we take a look at the initial side and the terminal side, it makes up an angle. And we're going to label that angle usually theta, the Greek symbol for theta. Theta is this funky looking zero with a line through it, and that's our angle. You've been used to doing like angle of A, but we don't do that anymore in pre-calculus. We do angle theta, and you can see angle theta here in the red is 120 degrees. And that's from the initial side to the terminal side. We're always going to start with the x-axis here at 0 degrees. And you can see we have 90 degrees, and we go all the way up to 120 degrees right here. But we can also come the other side, which is called the coterminal angle. The coterminal angle here is negative 240 degrees. So we start at 360 degrees, we're subtracting 240, and we still get the exact same terminal side. And we call those standard position and coterminal angles. And so as we take a look, we've been mainly measuring things in degrees in our lives. We've done 0 degrees, 90 degrees, 180, 270, 360 degrees. But we're going to start measuring in a new measurement called radians. And what radians is this, is if you take this radius, this distance between this point right here and the center, which we call the radius, which you know, once what we call the arc length, this side S right here, is the exact same length as the radius, then we call that angle, that's a specific angle, we call that specific angle 1 radian, or RAD. Which means we know if we make one full circle around, that's 360 degrees, that equals 2 pi r radians. So 360 degrees is equal to 2 pi, what we call radians, okay? Which means 180 degrees would equal pi radians, which makes logical sense because 2 pi times r equals the circumference. And we have this equation, the arc length, which is this arc on the distance around the curved edge of the circle, is equal to the angle in radians. That angle must be in radians times the radius. And we're going to use this as we go along. Now we have this thing called the unit circle, which I'm going to show you degrees. We have 0 degrees, of course. We have 90 degrees. We have 180 degrees. We have 270 degrees. And we're back to 360 degrees. Okay? And we also have other angles in between, don't we? We have other angles in between. Obviously, we have 45 degrees at that kind of right in between the 0 and the 90. We have 135 degrees. We have 225 degrees right here. And we obviously also have 315 degrees. Okay, these are at our 45 degree angles. Now we also have these angles in between, which we can call 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270, 300 degrees, 330 degrees, and then back to 360 degrees. So that is all of our degrees. In the blue, we have our degrees. Now, what would this look like in terms of what we call radians? Well, right here, of course, we have 0 radians, okay? And obviously, if we make one full circle, we said we're back to what we call 2 pi radians, which means one full circle is 2 pi radians. So 360 degrees, 2 pi radians are the exact same thing, which means pi radians is exactly 180 degrees, which means pi over 2, 1/2 of pi, would be at 90 degrees, and 3 pi over 2 would be here at 270 degrees. Which means, think about it, if half a pi is at 90 degrees, then a quarter pi, that looks awful, let me rewrite that, pi over 4, or a quarter pi. Okay, so let's count in our quarter pies, okay? So 1/4 pi, 2/4 pi, that's 1/2. 3/4 pi, 4/4 pi, that's 1. 5/4 pi, 6/4 pi, that's 3/2. 7/4 pi, back to 8/4 pi, that's 2 pi. So at the 45 degrees, the 135, the 225, and the 315, these are in what we call at the quarter pies. Okay. So here, right here, we have 1/6 of a pi. 1/6 of a pi. So let's count in 1/6. So we have, just like we count in 30, 60, 90, 1/6, 2/6. 2/6 reduces to pi over 3. 3/6. 4/6, which reduces to 2 pi over 3. 5/6 pi. 6/6 pi, which reduces to 1 over 1. 7/6 pi. 8/6 pi. 8/6 pi reduces to 4 pi over 3. 9/6 pi reduces to 3/2. 10/6 pi, which reduces to 5 pi over 3. And 11 pi over 6. And then we're back to 12 pi over 6, which is the same as reduces it to pi radians. So this is the blue is all in degrees, the red is all in radian measurements. Okay, and so you have two different types of degrees or angles that you can do. One is in degrees, one is in what we call radians. So here we're going to sketch and find some coterminal angles. Coterminal angles. Now remember, what is coterminal angles is we want to know what that coterminal angle is what's that angle that is the exact same but the smallest value of this angle. So first example, we have 13 pi over 6. So let's count in pi over 6s. We have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, 13 pi over 6. So that is this angle right here, which if we subtracted 2 pi, if you subtract 2 pi radians, and let's get common denominators. Let's subtract 12 pi over 6. We end up with pi over 6, and that is what we call our coterminal angle. That is what this angle is right here. So one way we can find our coterminal angle is we can subtract 2 pi. Okay, so let's take a look at our another angle. Okay, so we have 3 pi over 4. Where's 3 pi over 4? It's right here, isn't it? Okay, so we start here with our initial side. We're right here. That's awful. And so that is 3 pi over 4. So how would we know what our coterminal angle is? Well, our coterminal angle would be this angle right here. This angle right there would be our coterminal angle. What do we have to do? We have to subtract 2 pi. How do we subtract 2 pi? Let's get common denominators. 8 pi over 4. So what's 3 pi minus 8 pi? That's negative 5 pi over 4. So negative 5 pi over 4 would be my coterminal angle. Coterminal angle. Now, if you have take a look here, this last one is we have negative 2 pi over 3. Now, take a look. 2 pi over 3 goes from here all the way to here. So if we're going not in the positive region, which is counterclockwise, but we're going clockwise in the negative region, negative 2 pi over 3 would be to right here, wouldn't it? Okay, so that would be negative 2 pi over 3 distance away. So what's my coterminal angle? My coterminal angle is this angle right here, isn't it? That coterminal angle right there. So what can we do to find that coterminal angle? We can also add 2 pi. So let's add 2 pi. We're going to add, and we got to get common denominators. 6 pi over 3, that's 2 pi. And when I add this, I end up getting 4 pi over 3. And take a look. That is 4 pi over 3 right there. So you can do it either graphically or you can do it by adding or subtracting 2 pi to find, add or subtract 2 pi in order to find your coterminal angle. Okay? So that's example 1. Example 2 is finding complementary and supplementary angles. Now, remember what complementary means. Complementary means we are getting our to 90 degrees, right? Complementary is we're getting to 90 degrees. Okay, we're kind of taking 90 degrees and subtracting whatever angle we have. Think back to geometry. Supplementary is 180 degrees minus your angle right there. And so here our angle is 2 pi over 5. So let's find the complementary angle of 2 pi over 5. So remember, what is 90 degrees? 90 degrees is the same as 1 pi. Pi over 2. What is 180 degrees the same as? It's the same as 1 pi. So if I take pi over 2, and I'm going to get common denominators. So pi over 2 would be, we have to, so we're going to take, to find our complementary angle, we have to get pi over 2, okay, pi over 2. And we want to get common denominators. And so our common denominator would be 10. So we are going to do 5 pi over 10. That's pi over 2. Minus, what's this angle in over 10 is 4 pi over 10. We're left with pi over 10. That is the complementary angle. Complementary angle. If we want to know the supplementary angle, we're going to get common denominators. We're going to do 5 pi over 5 because that's 1 pi. That's 180 degrees minus 2 pi over 5. And what are we left with is 3 pi over 5, and that is what we call the supplementary angle. And so what are we just doing? We're taking 90 degrees, or pi over 2, and subtracting it, or 180 degrees, pi, and subtracting it. So let's try the second one. Let's try to find the complementary angle. We're going to get, again, we got common denominators. So we have our 5 pi over 10, okay, 5 pi over 10, minus 5 pi over 10, minus the common denominator, 8 pi over 10. Do you see how this angle is bigger than 90 degrees, which means there is no complementary angle, okay? But there is a supplementary angle. We can do 5 pi over 5 minus 4 pi over 5, and what are we left with is 1 pi over 5, and that is the supplementary angle right there. So that is how to find complementary and supplementary angles using radians. Now let's convert from radians to degrees or degrees to radians. In this case, we're going to go from degrees to radians. And so you can see, what do we know? 180 degrees equals pi radians. And so we want to do a little bit of dimensional analysis. If you're in degrees, you're going to multiply by pi radians over 180 degrees. Why? Because you got to get that degrees to cancel out. So we take 135 degrees. We're going to divide by 180. So 135 divided by 180. You do that in your calculator, you'll see it's 0.75. We put that in a fraction. That's 3 pi over 4 radians. Okay, so it's just like when we're doing dimensional analysis. Here again we're in degrees, so we're going to multiply by pi radians, divide by 180 degrees, and so we do 540 divided by 180, and we end up getting 3 pi radians. That's more than one full circle around, because remember, 2 pi radians is all the way around the circle. Okay, 3 pi radians would be 1.5 times around. Think about that, 540 degrees. It's more than 360. Again, pi radians divided by 180 degrees, and so negative 270 divided by 180, and we get negative 1.5, or negative 3 over 2 if you put that into a fraction, negative 3 over 2 radians there. Which means if we can convert from degrees to radians, we can also convert from radians to degrees. And so how do we convert from radians to degrees? You're going to do the reciprocal of what we just did. You can see in this one we took pi radians over 180 degrees, which means this one you're going to take 180 degrees over pi radians. And so you can see the radians cancel out, the pi cancels out, and you have negative 1 over 2 times 180, which is negative 90, and you can see what carries on is the degrees. Okay, so here we have 2 radians. We have times 180 degrees over pi radians. What cancels out? The radians cancel out. There's nothing to cancel out this pi, though. So we have 2 times 180. That's 360 degrees over pi. So we have 360 over pi degrees. In this last one, we times by 180 degrees over pi radians. Let's see what cancels out. The radians cancel out. The pi cancels out, which means we have 9 over 2 times 180, which ends up becoming 810 degrees. 810 degrees. So how do we go from degrees to radians? We multiply by pi radians over 180 degrees. How do we go from radians to degrees? We multiply by 180 degrees divided by pi. Or you can just do a proportion. Okay, so how are we going to find what we call arc length? How are we going to find arc length? Well, our central angle is 240 degrees. And we have this equation of arc length is equal to angle times radius. We know our radius is 4 inches. Okay, but remember this angle must be in radians. So we have 240 degrees. We're going to multiply by pi radians over 180 degrees. Why? Because the degrees have to cancel out. So we have 240 divided by 180. If you put that into a fraction, that ends up being 4 over 3. The pi continues, and we have radians. And now we're able to put it in the equation. Remember, this angle right here has to be in radians. 4 pi over 3. The radius is 4 inches, which means we have 4 pi over 3 times 4. That's 8 pi over 3. And what are my units is inches. Ultimately, radians is what we call unitless. Okay, so what is the arc length? Is if you do this, you can 4 inches, and then you continue the circle around 240 degrees. So you got 90, 180, before 270 right there. If you wanted to know what that entire length is, it would be exactly 8 pi over 3 inches long right there. 8 pi over 3 inches long. Now we can also find linear speed. Okay, so that we have the second hand on the clock, which is this hand right here. Okay, and we know it's 10.2 centimeters long, and we want to find the linear speed of this second hand. Okay, of this second hand. And so what do we have here is we know that in one revolution, this hand travels, in one revolution, it travels 2 pi radians. That equals 1 revolution all the way around the clock. Okay, which means you can see, if I want to know the arc length of this, equals your radians times your radius. Your radians is 2 pi. Your radius is 10.2 centimeters, which ends up being 20.4 pi centimeters. That is the length, that's the distance to go all the way around the clock. And what do we know? How many seconds does it take a second hand to get all the way around the clock? It takes 60 seconds, doesn't it? Which means we have 20.4 pi centimeters divided by 60 seconds, because we want to find what's called the linear speed. So what is speed? Is distance over time. Okay, distance over time, centimeters per second. And when I multiply this or divide it out, I end up getting about approximately 1.07 centimeters per second. And that is how we find the linear speed of the second hand. One last example here. We're trying to find the angular speed and linear speed of Mr. Aiden's first car. That was a babe magnet right there. That's called the Plymouth Sundance. She was a babe magnet. No, she wasn't. She kind of rattled if she got over 45 miles an hour. Anyway, let's take a look. We have a 15-inch diameter tire. We don't care about the diameter. We care about the radius. So 7.5 inches is the radius. It makes 9.3 revolutions per second. So, and we want to first find the angular speed in radians per second. So, really, guys, what's going to help out is units in this type of problem. So let's start with A. We have 9.3 revolutions per 1 second. Okay, 9.3 revolutions per 1 second. Well, think about it. if you make one full revolution, if the tire makes one full revolution around, that's 2 pi radians, doesn't it? 2 pi radians, which means what am I left with is 18.6 pi, 18.6 pi, and look at my units. The revolutions canceled out. I'm left with radians per second. Radians per second is exactly the units I wanted. Okay, but now we want to find linear speed. Now, linear speed is not in radians per second. It's in some sort of distance per time per second. Okay, so we want to take this 18.6 pi radians per second, and we want to make it into distance. Now, think about it, your equation. Arc length, which is distance, is equal to the angle, which is radians, times the radius. So all we have to do is multiply by the radius here, because we already have radians, the angle. We can multiply by 7.5 inches, 7.5 inches. And if I just take 18.6, let me do this in my calculator real quick, 18.6 times pi times 7.5, I end up getting 438.25, and what's my units is inches per second, and that would be the linear speed. This is how your car takes those revolutions per second or revolutions per hour and changes it into an odometer there. Okay, because obviously if you change the radius or size of your tire, if you're going all out boy, and you're changing the size of your tire, it's going to change your how your odometer, how fast you're going, things like that. So this was the first section of our new chapter, which is 4.1 radians and degrees measurements. Have a great day, guys. Catch you. Bye.